Welcome to aminacademy.com. In linear algebra, let us do some introduction. Linear algebra has in recent years becomes an essential part of the mathematical background. It uses teachers, engineers, computer scientists, physicists, economists and statisticians, etc. It's recent years it's very useful and it's in developing stage also. Linear algebra is a mathematical discipline that deals with vectors and matrices and more generally the vector spaces and linear transformations. Unlike other parts of the mathematics that are frequently invigorated by new ideas and unsolved problems, linear algebra is very well understood. Now let us further describe about linear algebra some more details. It is a branch of mathematics concerning linear equations such as linear maps and their representation in vector spaces and through matrices. Linear algebra is central to almost all areas of mathematics. For instance, linear algebra is fundamental in modern representation of geometry, including for defining basic objects such as lines, spaces and rotations. Also, functional analysis. A branch of mathematics analysis may be viewed as the application of linear algebra to spaces of functions. Now let us do some definitions. Scalar. A scalar is a quantity that only has magnitude and not direction. It is an element that is used to define a vector space in linear algebra. Scalars are usually real numbers. Vector. A vector is an element in a vector space. It is a quantity that can describe both direction and magnitude of an element. That means an element have its own magnitude as well as direction together. It's called a vector. Vector space. A vector space consists of vectors that may be added together and multiplied by scalars. Matrix. Matrix is a rectangular array wherein the information is organized in the form of rows and columns. Most linear algebra properties can be expressed in terms of matrix. Matrix operation. These are simple arithmetic operations such as addition, subtraction, multiplication that can be conducted in matrices. Also inversion, transformation also available in matrix operations. Linear transformation. The transformation of a function from one vector space to another vector. This represented preserving the linear structure of each vector space. Next, vector inverse of matrix. When the inverse of matrix is multiplied with the given original matrix, then the resultant will be the identity matrix. That means we know that A inverse into matrix A equal to I, that is identity matrix. Eigenvectors. An eigenvector is a non-zero vector that changes by a scalar factor, that is eigenvalue, when a linear transformation is applied to it. Next, linear map. It is a type of mapping that preserves vector addition and vector multiplication. Now we have some linear algebra topics also. That is, the topics that comes under linear algebra can be classified into three broad categories. These are linear equations, matrices and vectors. These main categories, from that subdivisions also there. All these three categories are interlinked That means these three equation, linear equation, matrices and vectors, it interlinked together. Now we know that linear equation means, for example, a1x1 plus a2x2 plus a3x3, like, means, look here, this linear equation general form is a1 x1 plus a2 x2 plus an xn. Now we can put values a, b, c, d or a numbers, that is real numbers, and x1, x2, x3 is some variables in terms of x. Linear equation are having one variable, two variable and three variables, multivariables also available. Then simultaneous equations, simultaneous linear equation, solving linear equation, solution of linear equation, graphing linear equation, application of linear equation, straight line. These are the some categories, some subdivisions under linear equation. That means a linear equation have one variable, two variable. Also we can solve it, and we can map, we can draw graph for this linear equation given. Vector. In linear algebra, there can be several operations that can be performed on vectors such as multiplication, addition, etc. Vectors can be used to describe the quantities such as the velocity of moving objects. Some crucial topics encompassed under vectors are as follows. Some types of vectors: dot product, cross product, addition vectors, inversion, like a lot of operations are there in vectors. Matrices. A matrix is used to organize data in the form of rectangular array. Can be represented AMN, means, for example, we can write one matrix here. Matrix is symbolized like 4, 3, 2, 1, 5, minus 5, 3, 0, 5. Suppose this is a, for example, one matrix 3 into 3, that is Mn is 3 into 3. Some matrix have only one row, it's a row matrix. Some matrix have only one column, it is called a matrix like. Now matrix have its determinant, transpose of matrix also there, types of matrix, lot of types of matrix we will discuss in future videos. Linear algebra, we have some formulas. Suppose look at here, general form of linear equation is ax plus by equal to c. The slope, we know that y equal to mx plus b, that is slope intercept form. Now here, that is addition of two numbers is it's one changes in order. That means a plus b equal to b plus c available. A plus 0 equal to 0. Addition of one real number with 0 is, and 0 plus that same real number equal to that one real numbers. Now let's, so for example, vectors u represented by u1, another u. This is a u2, u3, v3, u3, like vectors can be represented like v also, like v1, v2, comma v2, another v2, v3, another v3, like. Now addition of two vectors of u1, v is u1, v1, u2, v2, u3, v3, like it goes. Now modulus of that vector is square root of u1 square, u2 square, u3 square, like here this is squares here. Now we know that cross product of two vectors is like this or not. It's called determinant form also, you can find it. Matrix, if there are two square matrices given A and B where it's available, that is A, suppose vector Aij and vector bij, that is I is a number of rows, j is number of columns respectively. Then following important formulas are available. A inverse A is 1, that is inverse matrix with that original matrix multiplication is 1. Suppose vector matrix C equal to A plus B, that means we can add the respective terms of A and B matrix together. So respective terms, that is in columns first 2, 3, that's in columns first 2, 3. The elements in the any position is added with that other matrix with the same position. Suppose matrix is multiplied with some constant, also that every terms of the matrix is multiplied. Linear algebra has special applications, that is in signal processing and linear programming, computer science, prediction algorithms. Like here, still related articles are graphing, variable linear equation and inequalities, resolving a vector into components. Like here, look at this linear algebra. Add this to matrix, very simple. That means here this is a row matrix, this is also row matrix. So we have to have A plus B equal the respective numbers. 5 plus 3 is 8, 6 plus 7 is 13, 2 plus 5 is 7, 1 plus 4 is 5. This is the row matrix having added with the respective terms of matrices A and B. Like here, vectors have U vector is 3, 7, 1. V vector is, suppose here 1. Here, look at this, vector U is 3, 7, 1, vector V is 6 to 8. Using linear algebra, simply we can add them. This is, suppose we subtract this, subtraction of these two vectors. Look at here, that is U minus V is here 3 minus 6 is minus 3, 7 minus 2 is 5, and 1 minus 8 is minus 7. This operation, addition, subtraction, multiplication operation is there in vectors. Here, solve this equation. Simply we know that solving linear equations, look at for example, here, first is x plus 3 equal 2 into y is 2y minus 2, which gives x minus 2y equal minus 5, rearranged. The second equation is y plus 1 equal to 5x. That is here y plus 1 equal 5x is given the second equation. So we rearrange. This is 5x minus y equal to 1. Then how to solve is very simple. That is first equation write as it is, x minus 2y equal to minus 5. Then second equation multiply with 2, that is 10x minus 2y gives, multiplied with 2 is 2 into 1 is 2. Then subtraction give cancellation of y, that is x minus 10x is minus 9x, this cancel, and equal 5 minus 7, that was x equal to minus 7 over minus 9 is 7 over 9. Means one more time we check it, x minus 2 equal to minus 5, and here x minus 2 equal to minus 5, then y plus 1 equal to 5x means 5x minus y equal to 5x minus y equal to 1, then x minus 2y equal to minus 5, multiply with 2 to 10x minus 2y equal to 2, then solve it. Then substituting this x value in first equation, suppose x value is here 7 over 9 minus 2y equal minus 5, that is minus 2y equal minus 5 minus 7 over 9, which is equal 9 minus 45 minus 7. This is minus 52 over 9. Then y equal minus 52 over minus 2. 2 over 9 minus 6, 18. Here by cutting by 3 you can get it. 1 3s are 3, 4 3s are 12, then 3 is 6. Further you can write 7 over 3. So we get A is, that is x is 7 over 9, y is 7 over 2. This solve right. Here, like lot of information we have done so far, that means about linear algebra. Further videos we discuss more details and more problems we will solve. If you have done, please subscribe our YouTube channel.